Hello everyone. Welcome back to Dr. Lou's VCE Chemistry channel. Today, let's learn together about the 2023 chemistry examination. Now, we analyze the question and answer of spectroscopic techniques such as infrared spectroscopy, nuclear magnetic resonance spectroscopy, and mass spectrometry. These techniques are applied to analyze the structure of organic compounds. Spectroscopic techniques are the most difficult section in VCE chemistry. But this section is my favorite, and I organize a few simple skills to answer these questions. My explanations may be flawed. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. There are 7 different carbon environments, so 7 peaks should be observed in the 13C NMR spectrum. The base peak is associated with the most abundant species formed during fragmentation. The base peak represents the most abundant fragment produced in the relative height of the peak at that MZ ratio is set at 100. So, A is eliminated. Other peaks are measured relative to the height of the base peak. So, D is correct. The peaks are caused by the different masses of fragments. So, B is eliminated. The base peak can also be formed from fragments larger than itself. These fragments are not always molecules. So, C is eliminated. Only carbon, hydrogen, and oxygen are found in this compound. So, its molecular mass must be even. Its molecular mass is identified as 86. From its IR, we identify it as a ketone. So, the general formula is CnH2NO. We substitute all the atomic mass into this formula, solve this equation, and get the number of carbon is 5. The peak at 87 is an isotopic peak caused by the 13C isotope being present in the molecule. The doublet at 1.1 parts per million suggests that there is a single non-equivalent hydrogen located on an adjacent carbon atom, according to the N+1 rule. Referring to the datebook, we identify 210 as belonging to carbonyl, 41 as CH, 29 as methyl, and 19 as methyl. 41 corresponds to 2.7 in HNMR, which is split into peaks and 1 hydrogen. 29 is corresponding to 2.1 in NMR, which is 3 hydrogens and a singlet. 19 is corresponding to 1.1 in NMR, which is 3 hydrogens and doublet. Drawing any isomer of C5H10O is qualified for 1 mark. If this structure shows 4 carbon environments or 3 hydrogen environments, you are awarded another mark. But to acquire the last mark, you should draw a correct structure, which is an isomer of C5H10O, a ketone, and has 4 carbon and 3 hydrogen environments. Explain why different frequencies of IR can be absorbed by the same molecule. Almost all molecules are composed of different bonds and function groups. These different bonds have different strengths of bonds and masses of atoms attached to bonds. Also, the same bonds have different vibrations such as stretch, bending, or stretching. These differences have different energy levels and match different frequencies of IR. Therefore, the different frequencies of IR can be absorbed by the same molecule. There are 2 multiple-choice questions worth 2 points. There is also 1 short answer question worth 10 marks in this section. The overall score for spectroscopic techniques is 12 points. With a total possible score of 120 points, the percentage for this section is 10% of the total score. If you need my help, please add me on WeChat or WhatsApp, and send me an email. Thanks for your attention. Please note Dr. Lou's VCE Physics channel and Lou's VCE Chemistry channel.